Alright, 3.7 plus. This is where we are modeling linear equations, but we're using our calculator to do it. Alright, so we're going to be typing in x and y values, points, into our equation, and we're going to use those points to find an equation of a line. Typically, we're going to be using, at least in this section, we're going to be using lines. We're going to be finding equations of a line. Alright, so what you want to do is you want to type in these points here. Now in example 1 they already give you the answer. They've already typed in these data points in the calculator, and the calculator gave them this answer for their equation of a line. But I want to show you how you find that equation of a line. Alright, so let's look at this handout here, and I'll give you this handout when it comes time for you to look at this section. Okay, so for linear regression, there's a couple of things that you want to do once, or just at the very first start of doing these problems, and then you want to turn something back off when you're done doing these types of problems. So there's one thing that you only have to do one time only. It's called turning diagnostics on. So what you do is you hit second and then 0. Hit second and 0. It turns on your catalog. And now you're going to arrow down. Just hold the arrow down button until you get to the D's. You'll go through the A, B, C's, and eventually you'll get to D. And then wait until you get to diagnostic on. Notice my arrow is pointing right at diagnostic on. So hit enter. Okay? And then hit enter again. And when it says done, you've turned your diagnostics on. Now what that means is later on, you're going to see a number when you ask for an equation. You're going to see a number. It's called R squared. And your R squared number is going to tell you how precise your answer is. And sometimes R squared will equal 1, which is ideal, because it means you hit every single point 100%. Sometimes it's 0.998, which is really close. That's okay. Okay. Other times it's like 0.58, which is horrible. The farther away it is from 1, the worse your answer is. So if it's like 0.60 or 0.50, that's a horrible fit. It's not a very good answer. But if it's 0.888, 0.95, 0.99, anything like that, it's pretty good. All right? So you only have to do that one time, and you never have to turn it back off again. Just do that your one time. Now, you want to turn your plot 1 on. Now, how do you do that? You hit y equals, okay, and you arrow up 1, and you arrow up to plot 1. And when your plot 1 is blinking like that, hit enter, and then arrow back down, and it should look just like that with a black box around, black rectangular box around plot 1 like that. Okay, that means you've turned plot 1 on. What that means is the points that you type into your calculator will now plot those points on your graph for you, and you'll be able to see them on your screen. Alright, now when you're done doing your regression equations, when you're done with this section, you want to go back and hit y equals and go up to plot 1 and hit enter again and come back down, and that turns it back off. Okay, now I'm going to turn it back on again because I want it on for this section. Alright, so now we want to type in some data, and the way we type in data is we hit stat 1, and so stat is right here. See the stat button, S-T-A-T. Hit that, and then you type in the number 1. Okay, and you should always have numbers in there beforehand. If it's a brand new calculator, you won't, but typically after you've done one question, you'll always have the old numbers from the previous question. So you're going to want to arrow up to L1 or L2, it doesn't matter which one, and then hit clear. Don't hit delete, hit clear. And then come back down, and notice how they go away. Go over and up to L1, hit clear, and come back down. And notice they don't go away until you actually arrow away from the L1 or L2. Then they go away. Alright? So now you've gotten rid of all your old data. And now we're going to type in our numbers. Now here's our x values, here are our y values. And you're just going to type in one number at a time, and each time you hit enter. So let's type in all our x values under L1. So 0, enter. 2, enter. 4, enter. 6, enter. And so on. Okay, so 0 up to 16 by 2s. Okay, now you arrow to the right, and now let's type in our y values. 7.8, enter. 8.4, enter. 9.2, enter. 9.7, 7, enter. 9.4, enter 10.3, enter 10.3, enter 10.4, enter. And you might want to check your numbers, see I screwed up somewhere. I didn't do something right. So 8.4, 9.2, 9.7, 9.4, 9.7. And then 10.3, and that one should be 10.3, and that one should be 10.4. Always make sure you have just as many x's as you have y's. You should always have them paired off like that. And if you don't, you messed up somewhere. Alright, so now once you've done that, once you've typed in your L1 and L2, you typed in all your L1s, then hit second mode. Second mode. Okay? So now you want to find the equation for your data. Okay, so you hit stat, S-T-A-T, and you arrow to the right one, and then choose 4. 4 because it says linear regression. We're doing a linear regression. Okay, so now you want to hit enter, enter, enter. Okay, and now if you want your equation to be typed into your y equals screen, this is what you have to do. You have to now hit vars, V-A-R-S, and arrow to the right one, and then hit enter, 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 and there you go. So now that's your A. Your equation is the form y equals ax plus b, where a is your slope and b is your y-intercept. So your slope is 0.1525, and your b is 8.24666666667. And look at your r squared number. It's 0.877. It's not exactly 1. It's close. The closer it is to 1, the better, and 0.877 is pretty good. Right? Now if you want to see what your equation looks like, just hit zoom and then the number 9. And you'll see not only your data points, but you'll see your line. Okay? And so look at your line. Notice your line hits some points below and some points above, and some points it comes really close to actually hitting them. Okay? Now if you want to see your equation, just hit y equals and it's right there. Okay? And that's how you ask your calculator to find an equation of a line for you. Alright? So, let's see. That's from similar questions. Let's go back. Okay, so what we did here is we found this equation on our calculator. We typed in the data points and we found the equation. In example 1, they already give you the equation and they show you what it looks like on your graph, but I showed you all the steps involved. Now they ask you to find f of 15. Okay? Now you have to first check to see if 15 is okay. If you hit window, if your window can handle the number 15, then it's okay. Look at your window is bigger than 15. It's 17, 17.6. So you can ask it 15. Okay? So how do you do that? You hit second trace 1 and you just type in 15 and enter, and it tells you 10.53. And so 10.53 is your answer for x equals 15. Okay? So they ask you estimate the number of passengers in the year 2010. Remember, 1995 is year 0. So 2010 is 15 years later. So you got to type in x equals 15. So when we typed in 15, we got 10.534. So that's the number of passengers in billions that will ride whatever transit they're talking about here. Okay? So example number 2, we can do the same thing. So we hit stat 1, and we got to go up and hit clear, come back down, over, up and hit clear, come back down. And you type in 0, 1, 2, 3, 4, 5. Okay, and 17.61, enter. 69.08, enter. 114.58, enter. 169.73, enter. 235.69, enter. 318.32, enter. Okay, and so you got all your x and your y values there. And now if you want to see the points, just hit zoom 9. Zoom 9 shows you your points there. Okay, so you can see your points there. They're somewhat in line. There's a little bit of a curve, but they're pretty much linear there. Okay, so you hit Stat, arrow to the right, 4, enter, enter, enter. Vars, you hit Vars, arrow to the right, enter, 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 enter. 4 enters there. And you get 58.815, and you get 7.13 for your B. And your R squared is 0.987. That's really close. Okay, so now if you want to see your equation, just hit Graph, and there it is. And if you want to see your equation, there it is. Now you don't always want to go out to that many decimal places. Sometimes they ask you to round to 2 or 3. Okay, and so if you round it to 2 or 3 decimal places, you might say 58.8382 and 7.13. Just depends. All right, on the equation. Okay. So example 3, they give you some data points here, and typically when they give you the year, they let x equals 0 represent a certain year. So x equals 0 represents 1990. So 1998 is really 8 years later, so you got to type in 8 instead of 1998. And then 10, 12, 16, 20, and 22. You got to subtract 1990 from each one of these. So you got 8, 10, 12, 16, 20, 22, and then you got the same y values. You type all those in, and then you do your linear regression, you get your equation, this is what it looks like, and you got your slope, okay, and it's decreasing by 0.314 per 100, okay, and then they ask you what's f of 28, meaning year 2018, how many years after 1990 is 2018? It's 28 years, so you're plugging in 28 here for x, and you plug in 28 here for x and multiply it by that and add that, and you get 0.313559, so it means approximately 0.31 workers per year. Positive change of 3.31 workers per year. It's the number of injured workers is the amount of workers that were injured in the workforce, and it's actually decreasing per year. So fewer and fewer people are injured, but they still are. There are still people being injured. Okay. Example 4, it says houses sold in Orange Park neighborhood in the past month. Listed are their selling prices and the number of square feet. So the square feet are here, and the selling price in thousands of dollars. So 240,000, 235,000, 258,000, and so on. So you plot the data points, and you use the linear regression to fit the data. Okay, and you come up with this equation. Now it says predict the selling price if the square footage is 2,800. Well, you know x is your square footage, so you plug in 2,800 for x, and you multiply it out, and you get 317.918 thousand, or $317,918. Okay. Now example 5 says adults who are 55 or older who are still working has risen. The percentage of workers, people still working that are 55 or older, there's 40% this year, all the way up to 42% in this year. So it's increasing. Not by a lot, but it is increasing. Now they say let x equal 0 represent year 2000. So 2011 is really 11. 2012 is really 12. So 11, 12, 13, 14, 15, 16. And you type in 40.8 all the way up to 42.7. Okay, and they want you to round your numbers to 3 decimal places. So when you get your answers, you round it to 0.386, 36.576. Okay, and so your slope is positive 0.386% per year. And they want to know what's happening in 2020. Well, that's how many years after 2000? It's 20. So you plug 20 into your equation, and you get 44.29. So once you have an equation, they can ask you either one. They can ask you, here's x, what is y, or here's y, what is x. Or generally they ask you, what does the slope mean? And they give you an x and ask you for the y. That's usually what they do there. So let's go back to the very first question that we had. And the first question talked to us about billions of riders on a, public transit. Okay, so Year 0 is 1995, and year 16 is 1995 plus 16, which would be 2011. Alright, so this is how many billions of riders of mass transit there are. So you can see it's increasing in the number of people riding the mass transit each year. And so they want to come up with the equation for this. And so you type these in for your x1 and your y1 under L1 and L2. When you ask your calculator and it gives you this equation, you're going to round it to a number of decimal places. And then they can ask you interpret the slope, and that means positive 0.1525 billion riders per year. Okay, and what happens at x equals 15? Well, 15 is how many years after 1995? That's 2010. So f of 15 is when you're asking this thing for x equals 15. So you plug 15 in there and multiply it by that and add that, and you get an answer. All right. Example 2 again was the number of media tablets in use during the years 2010 to 2012, along with projected years 2013 to 2015. So 2010 is year 0, and each one is 1 year after that. And this is how many millions of tablets are being shipped each year. So plot the data points. So you draw all these points and you plot them, and you find the linear regression. So you do the steps that we did earlier, and you come up with this equation. You actually come up with this equation, 58.82x plus 713. And now they can give you some number like plugging in 14, and you plug 14 in there and multiply it times that and add that, and you get an answer. Okay? Example 3, where's example 3? Number of injured workers decreasing per year. So you got number of injured workers, and it's getting lower and lower and lower each year. Number of injured workers per 100. Okay, so you type in your data and you get your equation. This is your equation. And now they ask you to figure out what f of 28 is, meaning x is 28. And you multiply it times this number, and you add that number, and you get an answer. And you get that right there. So you can answer questions now once you come up with the equation, and your calculator will do the calculating for you. So this one tells you the price based on square footage. And so you type in these data points and you ask your calculator, and it gives you this equation. And now they say, what about a house that has 2,800 square feet? So you plug that in for x, and you get, this is the price of the house in thousands of dollars, $317,000. Okay? And then adults working longer. What's the percentage of adults above the age of 55 working? And so the percentage is going up each year. And so you type these data points into your calculator, and this tells you how the percentage of people 55 or older that are still working. And all you have to know is what the year is. You plug it in there, and it gives you a percentage. So x equals 0 represents the year 2000. So 20 is the year 2020. So you're plugging in 20 into that equation, and you get 44.29% is the percentage of people above the age of 55 that are still working. Okay? And so those are the first 5 examples. All right, so give me a second to get these in the right order. 1, 3, where's 15? 15, 5, 7, 9, 11, 17, 19, and where's 6? 6, 12, and 13. Alright, so there's not that many questions here, but each question takes a bit of work here to do. The first one is just like question 1 on your assignment, because I couldn't find one that was similar to it. So state whether the ordered pairs in the table model exactly by the equation. So if you plug 0 in for x, do you get 1 for y? If you plug in 1 for x, do you get 3 for y? If you plug in 2 for x, you get 5 for y. Yes, you do. So they're modeled exactly, since each point is a solution. Okay. Now the next one is just like question 1. So they give you the equation already. You don't have to use your calculator to find it. And it says x corresponds to the year, and f of x represents the amount of money in billions. And they ask you to find how much money was spent in 2015. So you plug in 2015 in for X into this equation, you multiply it out, and that's how many billions of dollars were spent on research and development in 2015. Number 3, adult one-day passes for Disney World are given by 2.7x plus 38.64, where x is the number of years since 1996. Find what year the price was approximately $50. So $50 is your price, and x is your year. Remember, x is the years since 1996. So when you solve this, you got to subtract 38.64. You got to divide by 2.7. Then you get 4.207, which is approximately 4 years. And that's after 1996. So 4 years after 1996 is year 2000. So in the year 2000, it costs about $50 to go to Disney World for one adult. I think it's actually more expensive than that now. Right? So question 15. They say use the equation 13 to predict the selling price of a house. So from equation 13 you get this guy here, and they say your input is 2,200, and you plug that in for x and you multiply it out, and that's the amount of dollars the house will cost. Okay. Number 5, they say use linear regression to fit the data. So you're going to have to type in these data. First thing you want to look at is what is year 0? X equals the number of years since 2000. So you got 2000 is year 0, so 2010 is really just 10. So 10, 11, 12, 13, 14, 15. Those are the numbers you're going to type in under L1, your X values, 10 through 15. And then your Y values are 270, 370, 362, and so on, all the way up. Alright, so you can type all those in, you do the regression equation, you're going to round it to 3 decimal places, and this is what you get. And now they say find the rate at which the number of smartphones shipped worldwide is increasing. Well, it's positive 102.504, so that's your rate of increase, your slope. So 102.054, positive 102.454 million per year. Then they ask you how many in 2018. Well, how many years after 2000 is that? Well, it's 18, so you're going to plug in 18 for x, and you get the number in millions. Okay. Number 7, you do this one, you do linear regression, and you come up with this equation. Okay, so remember, you're going to type in L1, you're going to type in L2, you're going to hit stat, arrow to the right, 4, enter, 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 and then you hit vars, arrow to the right, and then 4 more enters, and it gives you an equation. And that's your M. First number A is your M, and the next number is your B. Instead of MX plus B, they say AX plus B. Okay? And your R squared will tell you how accurate your number is. The closer it is to 1, the better. 0.9877 is very good. Okay? So, on this one, they give you this equation, and now they say predict the number of smokers in 2020. Well, year 0 here is 1960. So 2020 is 60 years later, so you're plugging in 60 for X, and you get 9.1% are smoking. And now C says, what's the percentage at which male smokers are decreasing per year? Well, it's negative 0.725, meaning it's dropping by 0.725% per year. They're becoming fewer and fewer males smoking. Number 9. Number of male prisoners in state and federal prisons, it's rising over the years from 2080 to 1980 to 2010. So year 0 is 1980, and this is every year, number of years after 1980. So you plug in these numbers, and you get this equation. And now they ask you, what about 2020? Well, how many years after 1980 is 2020? That's 40. So you're going to plug in 40 for X. And you get this number. Remember, that's in thousands. It says thousands of prisoners, so it's that many thousands. Or you just move the decimal over 3 places, and that's how many prisoners. And when you round it to the nearest thousand, it's 215,600. Okay, and they predict the rate at which it's increasing. Well, it's increasing by 47.143 thousand. So 47.143 thousand, or roughly 47,000 per year. All right. Number 11 says percentage of adults in the labor force age 65 or older, and so it's going up by the percentage of the labor force, and X equals the number of years since 1990. So this is 0, 5, 10, 15, and 20. And you type in those numbers along with those Y values, and you get this equation. And now they say, what does the slope indicate? Well, it's positive 0.212, and that's a percentage, and it's an increase per year. Increase in the percentage of the labor force that is above 65. What does the slope indicate? Well, it indicates an increase per year. Now, predict the number in 2020. Well, 1990 was year 0, right? 1990 is year 0, so 2020 you're plugging in a 30 for X. It's 30 years after 1990 is 2020, so you plug in 30, and that's a percentage you would expect to see in the workforce in 2020. 2017, they say come up with the equation, and you just plug in those data points, and this is what you get. All right. 19, you plug in those data points, and this is what you get as well. And they tell you what's the rate. Well, it's 0.268 per year. Then they say, what about in 2018? Well, you got to go back here and say X equals 0 represents the year 1900. So 2018 minus 1900 is 118. So you're plugging in 118 for X, and you get 80.213 is the life expectancy. Okay. We already did that one. All right. Number 6, the number of smartphones shifted or predicted to be shifted in the U.S. X is the years since 2000, so you're going to type in 10, because 10 years after 2000, 11, 12, 13, 14, 15, so on. And you type in these Y values, and you get this guy here. Now they say find the rate. Well, the rate is the slope, 26.351. If it continues, find the expected amount shipped in 2018. Well, it's years since 2000. That's 18 years, so you're going to type in 18 for X, and you get 274.475. Number of girls softball teams has grown, and here's your numbers, and it says X equals the years since 1970. So 74 is really 4, 84 is really 14, 90 is really 20, and so on. You can type in all those numbers, and you get this equation here. Now it says predict how many in 2015. Well, it's years since 1970. 1970 to 2015 is 45 years. So you're going to plug in 45 for X, and you get this number here. Okay. Now it says find the rate. Well, the rate is your slope. So 280.335 per year. That's the number of increase in softball teams per year. Girls high school softball teams per year. Okay. Question 13, there wasn't a similar one of that type on your homework assignment, so I just wrote this one down. I just took it straight out of the assignment. Now the tricky part about this one is they talk about comparing the different years from 95 to 2004, but they compare it with full service and fast service, fast food and full service. Full service is where it's a sit-down restaurant, where you go in, they give you a menu, you sit down at a table, and the waitress brings you your food. Fast food is where you walk in or go to the drive-thru and you take your food and go. All right. So they're comparing the two. All right. So now they want you to find a linear regression for full service and a linear regression for fast food. Well, the first thing you have to realize is this is really two tables in one. So if you want to know the full service, you just ignore the bottom line and you only focus on the first two lines, and you get this table here, which is just ignoring that bottom line of fast food. Now, if you want to do fast food, you ignore the line in the middle, and you only focus on the top line and the bottom line to give you your table. So this is really two tables in one. So you gotta, for full service, ignore the bottom line, and it looks like this. And for fast food, you ignore the middle line, and it looks like this. So once you got your two tables, you can type in both of your equations separately, and you get your two equations. Okay. And now they say approximate the year in which the two are the same. Well, what you can do is you can graph both of them on the same line, on the same graph. You can type one under Y1, another one under Y2. And then just hit zoom 9, okay? And you'll be able to see both of the graphs there. And now if you want to find the intersection, it's real easy. Just hit second trace 5, enter, enter, enter. And it'll tell you when x equals 7.312 years since 1990. Remember, x is how many years since 1990. So 7.31 years since 1990 is when fast food and full service are equal. Now fast food is going up. Full service is going up too. And at some point, what is it, year 7.3, let's see, that's how many years since 1990, so around 1997 these two guys are roughly equal. I think full service is going up faster. Yeah, full service is not as high as fast food, so full service is lower by 1995, but by 1997 it passes fast food, and that's where they're equal, but only for a short amount of time, and then full service surpasses fast food. But they're actually equal in 7.31 years since 1990, or approximately 7 years since 1990, which is roughly 1997. Alright, so to review, you first have to turn your diagnostics on, and you only have to do that one time. You never have to turn it off again, just leave it alone, so you'll never have to do step 1 after the first time. Now step 2, you have to turn this plot on when you first start doing these equations, and after you're finished with the regression you have to turn it off. So you hit y equals and you arrow up to plot 1, you go up to plot 1, hit enter and arrow back down, and you'll see a black box around plot 1. Now when you go to finish your regression equation and you're moving on to doing something else with your calculator, you have to turn it off, otherwise you'll get an error message. So you hit y equals again, arrow up to plot 1, hit enter again, arrow down, and you will no longer see a black rectangle around plot 1, and that means you've turned it off. Okay? So you have to turn plot 1 on when you first start doing these equations, and you have to turn it off when you're done doing these regression equations. Now to type in data, you always hit stat 1, arrow up to L1, hit clear, come back down, then arrow up to L2, hit clear and come back down. And then under L1 you're going to type all your x values followed by enter each time. And under L2 you're going to type in all your y values followed by enter each time. And then hit second quit or second mode. Now to find your equation, since we're always finding linear equations for this section at least, stat arrow to the right 4. Okay, then you hit enter, enter, enter. Then you got to find your vars button. Hit vars, arrow to the right, and then 4 more enters. And then you'll see your equation. You'll see your a and your b, and you'll even see your r squared. Remember, your r squared, closer to 1 it is, the better fit your numbers are. If you get r squared equals 1, that's great. Usually you don't. Usually you get 0.98 or something, or 0.95 or 0.87. And if you want to see what your graph looks like along with your points, you can hit zoom 9 and you'll see all the points that you typed in and your line. It'll graph both those on the same screen for you. And if you want to see what the equation looks like, you just hit y equals. But remember, when you're done doing your regression equation questions out of 3.7 plus section, turn plot 1 off. Otherwise you'll get error messages when you try and do your other problems.